So let us start with today's lecture. Let me give you a brief introduction about today's lecture. We are going to study heterocyclic chemistry, and with respect to our previous lecture, I have already informed you that please go through the notes of heterocyclic chemistry, which we have already learned last year. In that chapter, I have taught you furan, thiophene, pyridine, pyrrole synthesis. So today we are going to delve a little bit much deeper into heterocyclic chemistry. Now let me tell you the purpose of studying this subject, heterocyclic chemistry. You must have started attending lectures of drugs and dyes, right? DD. Now that applied components part is basically dealing with manufacture of drugs. But those drugs part which we are learning in TYBSc, only that much is not sufficient. जैसे कि अभी जैसे जैसे डिजीजेस सिवियर होते जा रहे हैं लाइक कैंसर एड्स एक्सेट्रा एक्सेट्रा the severity of pharmaceutical drugs also goes increasing. So do not be under the impression that only the drugs which are taught to you in drugs and dyes paper are the only drugs in this world. No, it is not the case. That subject, that drugs is more than what you're going to learn in TY. So the stepping stones of drugs paper is basically the origin is from organic chemistry. Because organic chemistry is only going to tell you how, when, what, and why you synthesize a molecule, right? So today we are learning heterocyclic chemistry because heterocyclic chemistry involves a lot of drugs synthesis which are used for targeted drug delivery. Now you must have heard this word first time. Targeted drug delivery is a study of organic chemistry wherein you have one small disease in the body. Say for example, you're talking about cancer. Now cancer, those dead cells accumulate at different parts of the body. If you use an anti-cancer drug, what that drug is basically doing is that drug is going to that particular target, that is your dead cell, right? Now, once it reaches that cell, if in the pathway, if you have kept that drug open, that drug will be hardening a number of substances which are coming in the way. जैसे कि अभी मेरा यहाँ पे elementary canal से I am putting the drug inside my stomach. It is passing through the stomach. It is going into the liver. It is going into the kidney. And if the cancer is lying in colon, colon is the last part of intestine. If it is lying at that part, then by the time the drug is reaching the target, that is colon cancer, it is already drained off. It has no potential to attack that cancer dead cell because it is already drained off. और पूरी तरह से वो exhaust हो चुका है पहले ही. So in order to keep the drug safe, okay, you encapsulate it. जैसे कि आप नॉर्मल कैप्सूल खाते हैं, कैप्सूल का ओपनिंग जो आउटर कवर रहता है, that gets opened only when you have a pH of the neck. Only at this pH that capsule opens, right? So यहाँ पे पास होने के बाद वो कैप्सूल धीरे धीरे ओपन होती है and then it is released into your stomach. Same way, those drugs are encapsulated, right? And once the drug, that encapsulation reaches your target, then you can understand that now your drug is going to act on that dead cell, that cancer, right? So इसकी वजह से this chapter is important because a lot of drugs involve heterocyclic compounds. Heterocyclic compounds में कौन से elements आते हैं? Atoms are sulfur, then oxygen, then nitrogen, phosphorus, etc. are there. But our syllabus is basically focusing at present only on nitrogenous compounds. तो nitrogenous compounds में हमने कुछ last year भी पढ़े हैं, जैसे कि pyrrole synthesis मैंने पढ़ाया है. Then I have taught you pyridine also. So today in TY we will be taking a step further, and then we will be understanding how those heterocyclic compounds can not only be synthesized but also the applications. ठीक है, तो हमें ये चैप्टर में तीन नाइट्रोजीनियस हेट्रोसाइक्लिक कंपाउंड्स पढ़ने हैं. Let us begin with the first heterocyclic compound. The first heterocyclic compound is do you identify this? Oh, sorry. This is O. This is O.
मैम ब्लर दिख रहा है.
ब्लर है?
यस मैम.
Okay. Hang on. Are you able to hear me now?
Yes.
Yes?
Yes,
okay.
ma'am.
Okay. Yes. So now this is your pyridine structure and this is your O, oxygen, minus. Right? This is your first heterocyclic compound. Hitesh Bhai, where are you, beta?
Yes, ma'am.
I am not able to see your video here. Yes. Okay. So first heterocyclic compound, the name is pyridine. Okay. N oxide. Pyridine N oxide. Structure draw करना is not that much difficult also. If you just pay attention to the structure, is basically comprising of your pyridine structure. If you just eliminate your oxygen, now this nitrogen is sharing 4 bonds. If you go down to your basics, nitrogen's valency is 3, and if nitrogen has 4 valency, then it becomes a quaternary ammonium. I repeat, so nitrogen valency is 3. If it shakes 4 hands, it becomes quaternary ammonium. So this is basically N plus मतलब क्या quaternary salt बन गया. So it is shaking 1, 2, 3, 4 hands. That is why nitrogen के ऊपर positive charge बनता है. And oxygen is electronegative. So that is why.
Yes, ma'am.
That is why you will have negative charge on oxygen atom. Right. Now, the second heterocyclic compound is you have a benzene ring and you have nitrogen present over here. Okay. Such a type of compound is a bicyclo compound. What is it? A bicyclo compound. Its name is quinoline. Its name is quinoline. Now, let us move a little bit further. Third heterocyclic compound in this chapter is just a small sister or a small brother of quinoline. This is going to be isoquinoline. This is going to be isoquinoline. Now, the structural difference is just over here. Nitrogen from this position is shifted to another side. So this is isoquinoline. Right? I think Hitesh is facing some issues, technical issues. Nikhil Dattatray? Nikhil Dhole?
Yes, ma'am.
Can you please on your this thing video? Nikhil
Yes,
Dhole?
ma'am.
Yes, please. I think Hitesh is facing some issues today. So, we are understanding that there are 3 structures on the board written, and we will be having to understand the synthesis, not only the synthesis, but also the applications. Right? Nikhil Dhole, again you have some problem about of the this thing video. I'm not able to see you, beta.
मैम वो नेट ठीक से नहीं है मैम इसलिए.
तो किसी का भी कनेक्शन आज नहीं है क्या?
मैम ठीक से नहीं चल रहा है मैम, अटक रहा है बीच में, इसलिए बंद करके रखा था.
Okay, fine. ठीक है, as you wish. Fine. Now, हम लोग क्या पढ़ रहे हैं? pyridine N-oxide is the first heterocyclic compound, quinoline is the second, third is isoquinoline. Now coming to the nomenclature. Nomenclature में हम लोग numbering किस तरह से डालेंगे? I am trying to make you understand. Please pay attention over here very carefully. So this is my heterocyclic compound. I will be giving number 1, 2, 3, 4. Then I will leave this ring. I will leave this ring and I will go to another ring. This is the protocol. Okay. So this is 5, this is 6, this is 7, and this is 8. Then the protocol also says that because it is a bicyclo compound, you have to number these two carbon atoms with the carbon atom present just before it. जैसे कि this carbon, just before this carbon you have the fourth carbon atom. So ये fourth carbon atom का मैं बोलूँगी 4A. This carbon atom, just before this carbon atom you have 8. So this carbon atom will be called as 8A. So the nomenclature goes this way: 1, 2, 3, 4, 5, 6, 7, 8. This is 4A and this is 8A. Is this much very much clear to you, children?
Yes, ma'am.
Okay. Now let's move a bit further.
Ma'am, 4A or 8 is carbon or what?
4A and 8A, both the positions you have carbon atoms, but the numbering will be in such a way that it has to be numbered with the carbon atom just before this carbon atom. इसके पहले ये कार्बन एटम है तो इसका 4 और ये A. इसके पहले ये कार्बन एटम है so इसका A and this is A. This is a protocol to name the compound. Follow, Sagar?
Yes, yes.
Yes, beta. Okay, now children, let's move to isoquinoline. Isoquinoline का just there is one difference in the structure is that nitrogen का position जो कि यहाँ पे था, now it is going to be shifted to this hand side. तो इसका nomenclature क्या है? इसका nomenclature change नहीं होगा. जो quinoline का nomenclature था, वही nomenclature इसका भी होगा. Because the position is changed, that will not hinder any type of nomenclature rules. So, same rule I am applying to isoquinoline also. I will straight away write down this carbon as 1, this is 2, 3, 4. 4A, 5, 6, 7, 8. 8, 8. This is how you give the nomenclature. Is this much clear, children?
Yes, ma'am.
Okay. Now let us move a bit further. I am going to talk about things called as electrophile.
मैम
Yes, beta.
मैम उसको 1A नंबर नहीं कर सकते?
Over here, are you talking about this?
यस मैम.
Yes, you can. See, कैसे रहता है? ऐसे nomenclature ऐसे भी दे सकते हैं. बहुत ज्यादा तरीके हैं. जैसे कि if I am putting 1 for this, then I can put 1 dash. Okay. This is 2, I can put this 2 dash. This is 3, I can put this 3 dash. This is 4, I can put this 4 dash. तो ये भी एक तरीका है. अभी तक मैंने आपको I have not taught you IUPAC nomenclature. So in IUPAC nomenclature, it is particular chapter which will be dealing with these types of nomenclatures only. But as of now, I don't want to confuse you with these types of nomenclatures. तो मैं कैसे जितना I am trying to make it simple for you to understand, or not only understand but keep in mind also. जब हम IUPAC का chapter चालू करेंगे, then these types of various nomenclatures we will be coming across in that particular chapter. Got it, Shivangi?
Yes, ma'am. Thank you, ma'am.
Yes, my child. Now, yes, coming back to, I was talking about electrophile and I was talking about nucleophile. To recapitulate you, I had explained to you, electrophile has a positive charge. Why is it positively charged? Because it has already lost the electron and now the number of protons are more. right? That is where the positive charge arises. If you remember, I have spoken to you about nucleophile. Nucleophile ने क्या किया है? It has accepted an electron, and now the number of electrons are more as compared to your protons, and that is the reason why it is gaining a negative charge. So now you have to understand certain positions which are more prone for electrophilic substitution. Electrophilic substitution. So when you talk about quinoline, okay, when you talk about quinoline, the two positions which are more prone for electrophilic substitution are number 5, this one, and number 8. Okay, number 5 and number 8. So I will write down in this fashion. I'm talking about isoquinoline. I'm talking about quinoline. Quinoline is my second structure. So the electrophilic substitution will take place at position number 5 and positions number 8. Then when I'm talking about pyridine, pyridine में 1, 2, 3, 4, 5, 6. ये तो सबको पता ही है. So position number 2, position number 4, and position number 6. So in quinoline you have 2, 4, 6 electrophilic substitutions taking place. Again, now I am going to isoquinoline. Isoquinoline का behavior भी same रहेगा जैसे कि quinoline था. So again for isoquinoline you have position number 5 and position number 8 for electrophilic substitution. So these two positions are more prone for electrophilic substitution. So on the board, I have explained to you two major important questions. Question number 1. Okay. Question number 1 is, why is the 5th and the 8th position more prone for electrophilic substitution? This question applies for quinoline as well as isoquinoline. Then, question number 2. Why are the 2, 4 and 6 position more prone for electrophilic substitution? तो इस सब का मैंने जो आंसर है लास्ट ईयर आपको मैंने रेजोनेटिंग स्ट्रक्चर्स सिखाए हैं. रेजोनेटिंग स्ट्रक्चर्स में मैंने अटैक ऑफ, आई विल एक्सप्लेन टू यू दिस वे, attack of electrophile. I am talking about quinoline at this particular point. So I have my benzene over here and I have the structure complete, and I am talking about this fellow. यहाँ पर I have taught you E plus and H. This is my position number 5th. Then when I am talking about position number 8, I have this type of the structure. E plus and 8, right? So this is your 8th position and this is your 5th position. So these both the positions are now, I have already taught you the resonance structures last year. So what I want you to do is, where I am depicting and I am asking the electrophilic substitution, I want you to go down to your notes of previous years, and the question I am giving for homework, I have explained to you what is going on over here. So now you start writing. Give down today's date. Write down today's heading, heterocyclic chemistry. Write down structure number 1, structure number 2, structure number 3. Write down the substitution positions of electrophilic attack. Write down this structure. Write down this structure. And let me know when you are ready for the question. Followed everyone, bacha लोग?